down so I can slow my compressor down so I can lower the amount of boost going into the engine. I'm going to divert some of the exhaust that would normally turn this away from it. I'm going to open a valve, and some of the air that would normally be driving this is going to go out this valve and go out of the engine. And the valve is called a wastegate. Okay? Now, this is an older style setup in that it used a calibrated spring, and when the pressure in the compressor side got beyond that of the spring would allow a shaft to move and open the wastegate. Very inefficient. So what we do in our world is, let's see if I got a better picture of that. Actually, I kind of sort of do. I have an air source that comes into my diaphragm assembly. And the air source pushes on a diaphragm against the spring and opens my wastegate. So if I could supply air to this diaphragm at specific points in time when needed to lower the boost, that would be optimum, wouldn't it? And that's what we do. I have a solenoid that has air pressure sitting on it, and that solenoid is controlled by the engine's computer. Okay? So I've got air sitting here. This goes to my wastegate. So when the engine, as reported by the various sensors on it, detects a need to lower boost pressure, it will energize this solenoid, open the valve, and apply air to the diaphragm, and then the diaphragm will open the wastegate. As the situation changes, and the engine needs more boost because I need more torque, as reported by the various sensors on the engine, air will be reduced or eliminated, and the wastegate closes. Follow? Okay, now.
It's like an on-off switch.
No, it can be modulated.
You can modulate your boost with that?
Yep.
Like pulsing it?
No, you can modulate the position of the wastegate so you can vary the speed. It's not just max speed, min speed. It can be varied throughout the RPM range.
So they don't run VGT?
No, VGT is different.
Yeah.
Variable geometry. I change the size of the chamber, and I change the size, I change the amount of air striking the impeller.
Yeah.
This one just diverts. This is the cheapest of the bunch.
Yep.
I got variable vane, variable geometry, and wastegate and turbo.
You have to have the wastegate with the turbo, all turbos, or
If I'm racing, I just got a pop-off valve. When I hit a certain pressure, it just opens up. You hear it in Formula 1 all the time. You hear pop, 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 pop. That's a pop-off valve on the turbo.
You said it expels the excess exhaust out of there, right?
What it does
where
is.
about does that?
Hold on. I think, you know what? I'm going to let you guys watch this video because it may, or it should actually. It might get my bag. It should. Oh, come on.
The principle behind today's turbocharger is simple. Get more power without increasing engine size. To increase engine power, you could add more and more fuel. But soon, you'd be wasting fuel, because the fuel needs air to burn. Actually, it needs the oxygen in the air to burn. At sea level, there is 0.016 pounds of oxygen per cubic foot. At higher altitudes,
That's a bit
air is
stagnant.
thinner and there's less oxygen. For example, at 5,000 feet, there is 0.013 pounds of oxygen per cubic foot.
That's the green
And at
line.
15,000 feet, there's only 0.010 pounds of oxygen per cubic foot. So, at higher altitudes, there's a greater demand for air to supply an engine with oxygen. In a naturally aspirated engine, the air is pulled from the atmospheric pressure surrounding the engine into the combustion chamber on the intake stroke of the cycle. As the altitude increases, the atmospheric pressure drops and the air available for the engine decreases. With less air available for combustion, the fuel is only partially burned and escapes out the exhaust as black smoke. The turbocharger helps supply air by forcing it into the combustion chamber under pressure, where the air is then mixed with the pressurized fuel to make a highly intense and more efficient combustion of the air-fuel mixture. The spent gas is then forced out by the piston during the exhaust stroke, and the cycle starts over. Turbocharger technology evolved from mechanically driven superchargers, which created boost power in relation to engine speed. But an inefficient supercharger is an engine parasite. It uses too much power to drive its own mechanism. For example, a supercharger that could, theoretically, raise a 220 horsepower engine to 370 horsepower can only manage 320 horsepower. The supercharger itself needs 50 horsepower to run. Because a
That's
turbocharger
the
runs
problem.
on engine exhaust, it puts much more power back into the engine than it steals. It's this advantage that caused Allset to begin developing turbocharger technology in 1954. And this is the reason why most diesel-powered trucks have turbochargers today. Inside a turbocharger, exhaust gas is channeled into the turbine housing. This exhaust gas then turns the turbine wheel. The turbine wheel turns a common shaft that connects it to the compressor wheel. The compressor wheel draws filtered air into the compressor housing, raising both its density and pressure, and forces it into the engine. The center housing contains precision, full-floating journal bearings. The bearings ride in a film of oil to keep the turbine and compressor wheels turning smoothly at high operating speeds. Also contained in the center housing are the dynamic seal rings, commonly referred to as piston ring seals. They form an airtight seal around the shaft to prevent the oil from flowing out of the housing, and to prevent the intake air and the exhaust gas from entering the housing. The center housing also contains thrust bearing, oil slinger, thrust washer, oil baffle, and journal bearing retaining rings. Airflow is controlled by the design and speed of the turbine and compressor wheels. There are 4 basic turbocharger designs. The single-entry turbo has a snail-shaped passage to channel exhaust to the turbine wheel at a constant velocity. Air that leaves the compressor wheel at high velocity and low pressure then passes through a diffuser to transform the flow to low velocity and high pressure when it reaches the combustion chamber. The divided or twin-entry type of turbocharger gets its power from the time differences in the firing order of the engine. Bursts or pulses of exhaust push the turbine at higher speeds than are possible with constant pressure turbos. The new generation of turbochargers include wastegate turbos and variable geometry or VG turbochargers. Both are designed to limit boost pressure at high engine speeds and loads. Because new emission regulations require higher boost to improve combustion, it is necessary to limit excessive internal engine pressure, which can damage engines and turbochargers. A wastegated turbo has a factory-set control rod, which forces the wastegate open at a predetermined boost pressure, which relieves some pressure on the turbine and reduces turbocharger speed, thus lowering boost pressure. The VG turbocharger is a breakthrough for engine designers striving for more torque at low speeds, better transient response, cleaner emissions, and improved fuel economy. In the simplest VG design, a pneumatic actuator allows the turbo sidewall, or shroud, to move aside when boost pressure is too high, which relieves pressure on the turbine and protects the engine. A more sophisticated VG design electronically controls air pressure in the actuator by means of a valve connected to the engine's electronic control module.
That's what we use on our
This
way.
assures peak turbo performance under all conditions of engine speed and load. Today's modern high-output diesel engines are designed from the ground up with a high-efficiency turbocharger. Turbochargers increase diesel engine fuel efficiency, which helps in meeting today's stringent emission standards. They also help quiet engine noise. Without the turbocharger in place and working at maximum efficiency, these engines would become extremely overloaded thermally, and performance would suffer. Many turbochargers that are brought in for service aren't themselves defective, but are mistakenly
This is a very long, it's a good video, and I use it for my turbo class, but I wanted to use the first portion of that to give you an idea how it works. Okay. So we have that wastegate connected to a solenoid valve that supplies airflow to the wastegate based on the engine's demand. So it's a computer controlled wastegate, basically is what it is. So we get more precise control of the air, so we can get more precise control of the fuel, and we can get a better handle on our emissions. You spilt over there, didn't you? The other day, you're gonna like this. Went to make coffee, put the mix, the grinds in, things. Forgot to put the carrot under the coffee. Walked away outside the room. It was the one Friday I was by myself. It was not last Friday, the one before that. And I got tied up on a phone call, and all of a sudden it dawned on me right in the middle of the call. Oh, crap. I said, hey, man, I got to get back to you. And I hung up, flew it here, and it's just, I was like, well, there you go. This reminded me of that when I saw you clean it up. So that's how we do our cleaning on that, is when we overflow the coffee maker, everything gets clean. Which, for me, it's usually monthly. All right, now, so that's the basic principle of operation of the turbo. It's a pump. Now, you could argue with an engineer, and the engineer would tell you there is a little bit of a power loss to run that turbo, because the engine has to work a wee bit harder to force the exhausts out of the engine and through the turbocharger, and that would be a valid argument. How much of a loss? Negligible. Certainly a whole lot less than a blower.
But it's reutilizing the exhaust.
Yeah, that's a great, I like that, Mike. That's very good. You're reutilizing what otherwise would be just wasted going out through the tailpipe is being put to use. So in essence, so if it cost you a few pennies to save $1, it'd be worth it. Okay, and that's basically what the turbo is. What otherwise would be blowing out the tailpipe is being used to add additional boost air into the combustion chamber so we could burn more fuel, release more heat, but still maintain our emissions level, our emissions output.
The Volvo's used up for engine braking too.
Yes, that's quite common. So what that does is it creates an artificial restriction in the exhaust stream, causing the engine to slow down and work harder to exhaust the gases, and in essence, to slow the vehicle down.
And at the same time, when you restrict the exhaust, you actually build more boost. So by shoving more boost in there, the engine has to work harder to compress it.
Yeah.
So you slow the crank like that too.
Yeah, creates a lot of heat.
Does the motor have to be lower compression for the turbo?
Typically, an engine designed from the ground up as a turbocharged engine will have a little less compression ratio because it makes up for an air volume.
Oh.
Typically.
You'll overdo it if you.
Since the turbo uses the same oil from the engine,
Yes.
they have to put more, or
No, Usually, well, when the engineers design the engine, then they design the lubrication system, they take into account the turbocharger. And actually, yes, you would, because a lot of your turbo engines will have additional quarts because they need to sit in the pan and cool longer versus a non-turbo. So let's say you had a turbo Mitsubishi, it might be 6.5 quarts, where a non-turbo Mitsubishi might be 5. Because they need that additional volume of oil to cool down because of the extra heat load put on the lubrication system by the heat generated by that turbo.
Can you actually have leaks from the turbo?
Oh, sure. Absolutely.
What's a cool sound is the turbine coming out of the exhaust.
Speaking of cool sounds, I happened across this video. Actually, I got it from Cummins. It's about counterfeit turbos.
Really?
Yes, hopefully I can get it to play.
Hey,
here.
does the turbo affect the longevity of them? I've heard that the lower end, is it harder on the motor a little bit?
If the engine's designed to run a turbo,
Yeah,
then no.
okay.
Because the metallurgy will be different than a non-turbo. That's why typically turbocharged automobiles are more expensive. In addition to paying for the turbo, you're probably paying for higher quality metallurgy in the engine components.
Oh, yeah, yeah. that
Let me
makes
see if I can find that video. It doesn't want to play in the link.
All the way down to wider
Hang on a minute, guys.
Counterfeit link.
Yeah, I don't know what.
You don't wanna share with us?
I know, I'm not having a good day today with this.
You get better fuel economy, more power,
Cummins Turbo Technologies are the world leaders in the design and manufacture of turbochargers for the medium to heavy duty.
Well, could be good size. Could be, yeah, you can find apples and oranges. Depends on the engine size. And then factory turbos are not meant to really.
I don't know why this thing is just messing with me
They're
today.
small, little baby turbos.
Yeah, hang on, let me get this going and then we'll do that because
Design the exhaust ports, much flow comes out of it, how big the turbo is. It's like too big of a turbo will take off the spool, too small of a turbo, it'll spool quick with that. It'll build a whole lot of boost on the high end. And oil viscosity even, because you shaft drag.
Do you like supercharger?
Nah.
yeah, why don't you guys take about 10 minutes, come on back about 10 to 9. Hopefully I get this thing to work.
Why do you like turbo better than supercharger?
Yeah, no. Not cause what? Okay.
You make money on the side.
Oh, yeah. I tried for a long time.
What do you charge, or, I mean, are you, mobile?
I try to stay away from the mobile stuff. I'll do it if it's an emergency, but
You don't do anything at your place?
Yeah.
Oh, you do do that, but.
yeah, I got my garage set up like a shop.
There's no, the overhead is included.
Exactly. Yeah. Makes it easy.
Alright,
Cummins Turbo Technologies are the world.
alright, take a break and then we'll show this. This is a video of counterfeit turbos blowing up. It's actually kind of cool. So we'll come on back around 5 to 9.
Truck guys, I got Cummins guys, I got the Allison guys.